Okay, good afternoon, everyone. I hope you're all well. Welcome to SDSC's Data Science Roundtable. We're absolutely delighted to have Dhiraj Pangal here join us today. I'll just take a moment to introduce our guest before we go into the thrust of the topic, which is AI tools for the modern surgeon and scientist. Dhiraj is a neurosurgery resident at Stanford University with a background in neuroscience and medicine from the University of Southern California. His work is at the intersection of clinical practice, computer vision, and surgical data science, with a focus on translating operating room video into actionable real world insights. Dr. Pangal has built products, led multidisciplinary teams, and published extensively on the development and deployment of AI systems in clinical environments. From early stage innovation to practical implementation, he's particularly interested in how clinicians can leverage today's tools to move from idea to execution, transforming surgical data into meaningful improvements in care. At SDSC, he serves as a clinical data science and customer success consultant, collaborating across engineering and clinical teams to design and refine platforms that deliver measurable value to surgical partners. We're absolutely thrilled to have you here today, Dhiraj. So over to you. Thank you.
Thanks so much, Rachel. Thank you everyone for having me. It's a real treat to be able to give, kind of lead this session. Thanks for the very kind introduction. I've been a part of the SDSC team now for a number of years, kind of since its very earliest of days, and has been really a pleasure to watch it grow, mostly as a fanatical cheerleader, but at times providing some sort of helper insight along the way. So today, I think is a slight departure from I think some of the past data science roundtables that we've had, but I think this is an interesting topic, very relevant, and one that in discussions with Dan is something that I think we both, I won't speak for him, but I feel strongly about that needs to kind of be discussed with the medical, clinical, and data science community at large. I think he'd feel the same way as well. But I wanted to spend a little time today talking about artificial intelligence tools for the modern surgeon, the modern scientist, the modern data scientist. And kind of go through what I would like it to be is a sort of practical guide on how to potentially use some of these tools. I know that there is a wide variety of people that are kind of in this session, whether that's clinicians, surgeons, people at all levels of training, data scientists, computer scientists, people who are in the clinical data science world but are not necessarily technical. And so, the principles I think in this talk can be applied broadly. And so I'm hopeful that it's helpful in that way. A little bit about me. I'm a Stanford neurosurgery resident. I have a background in the neurosciences with an emphasis in computation. I have spent a lot of my time kind of at the intersection of healthcare and artificial intelligence. Um, uh, Help make our practices better, and help take better care of our patients. I'm going to go through a lot of tools that are a part of companies in this talk. I have no conflicts that are relevant to this to the companies that I'm bringing up. I use pretty much all these tools myself, and I pay for a lot of them myself. They don't pay me. And I'll also touch base on that a little bit in terms of how to like actually logistically go about using some of these tools. Um, and so with that, we can go ahead and get started. The things I'm hoping you can walk away with this talk are one, to kind of remove some of the mystery around some of the AI tools that exist today. We're all familiar with some of them, and we see them in the news a lot. Whether or not they make markets go up or down is kind of dependent on the day of the week. And so I hope to qualify some of the hype and give you a better sense of where we are, where things can go, and what seems reasonable or unreasonable, not only in the broader context of the world, but also specific to what you do in your day-to-day job. Um, I'm hopeful that I can give you a little bit of a toolkit to try something new and not just say, yeah, this field is progressing, 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 and I'm gonna eventually catch up with it, but hey, I'm going to try to keep up with it now, even in a small way, shape, or form, but not just in a way that's academic or in a way that's cute or fun, but in a way that's actually helpful. And then lastly, I'd like to put you in the driver's seat. I think there's a lot of creative ways that these tools can be used to actually increase the productivity that you have on a day-to-day basis. And it can be done in a safe way. Um, and so with that, I think how I've structured this is we're going to go from the most vanilla, as I just kind of describe it, things that we all kind of know about, and then venture towards kind of the more frontier things that are where the future of the field may be going, but may not be kind of ready for prime time just yet. And so the analogy that I think kind of can help guide our whole discussion. Oh, and also, by the way, unfortunately, my internet connection is a little poor for some reason here. I'm at home, but today is not being great. So if I ever freeze or anything, if someone just let me know and I'll stop sharing my video and hopefully my audio and everything will continue. But okay, thanks, Rachel. So the analogy that I think can help guide us is to think of artificial intelligence as the intern who types fast. Uh, if you're a medical doctor or for a practicing clinician or someone who manages teams, you know this kind of archetype. That's someone who's full of potential, occasionally wrong, occasionally very wrong, and occasionally very overconfident about what they can and can't do. Um, and that doesn't mean that interns and working with interns aren't a very delightful part of a job. And doesn't mean they can't be very, very productive in terms of getting you where you need to go. It just means you have to know how to direct them and that you have to take it like a job. And that's kind of the approach that I think is the safest approach when you're dealing with artificial intelligence tools, especially surrounding the kind of higher stakes environments that the people on this call would likely be engaged in. And so there's kind of three principles of artificial intelligence stewardship that I think are very important to go over before even getting into anything in terms of the actual tools. And this is, I'm hopeful, the framework that can help you kind of decide whether it's even worth exploring an AI tool, whether it's worth trying it out for the first time, deciding how you want to go about using it. I don't think that's commonly taught, and there's no kind of best practices for this. And so this is a framework that I've kind of put together in conjunction with some others to kind of help guide that. The first is that verification is everything, and you need to verify everything. Just as if an intern is going to submit a proposal on your behalf, you're going to read through that proposal, you're going to fact check it, you're going to proofread it. If you have an intern that's writing code for you, you're going to spot check that. Or if they're producing data for you or producing analyses, you're going to spot check that, or you should. Um, and ultimately, what gets output into the world is a reflection of you. And so verifying the outputs and making sure that the outputs are maintain the standards that you have set as important is kind of the first principle. And if you get lazy doing that, you're going to run into problems. And when you see some of the horror stories, quote unquote, of people using artificial intelligence, part of that can come back to failures of one of these AI stewardship principles, and oftentimes it's the failure of verification. Um, the second is to protect sensitive data, and this goes without saying. This is incredibly important in all situations, in all contexts, but even more so when you're dealing with sensitive information, healthcare data, whether that's the governance that's deployed by your hospital or your company if you're out in the industry in terms of what you can and can't do, or whether that's kind of more federal statutes like HIPAA. You cannot just pass sensitive data through the frontier AI labs like, ChatGPT's API, et cetera, and get data and get, information back, because now you're sending that data over to them. And so there are workarounds for this, of course. Now, many companies have enterprise levels of, essentially private deployments of these frontier models that employees have access to. And so, that's a growing kind of business. And so, that could be a possibility for you. It could be that certain, some of these workflows that you think AI is going to be really helpful for just may not be ready for you just yet because of the data agreements that need to be put in place. I know everyone on the SDSC front is very, very familiar with the ideas of sharing data and sensitive data. And so that really needs to go, that cannot be overstated, if you ask me. And then the third point, which I think sometimes gets overlooked, is this idea of time saving and productivity optimization. For many complex tasks, I actually find that the ability for artificial intelligence to give you productivity gains is less so in that it takes a task that takes 5 hours and reduces it to 1 hour. Sometimes that is the case, and that's great. But really, it's the ability to iterate quickly. It's the ability to spend time thinking and planning, and it's the ability to create an ultimately higher level product or higher level experience or higher level output than you would have done on your own. But actually, you find you end up spending a fair amount of time working with it and developing it and creating it. And so the point is that these AI tools should try to elevate, not replace. And you should think of, how do I use these AI tools to not cut down on my work? Again, sometimes that is the purpose of them, but for a lot of the kind of complex tasks that you or I go through on a day-to-day basis, it's not just going to be a total one-to-one replacement, but it could actually make it so that the end result of what you produce is much better than what you would have on your own. And so these three principles are going to kind of, I'm going to keep referencing them. And as we move forward, I think they're good to plug back in and say, okay, when you're looking at this case study or this example, have we really abided by the principles of AI stewardship? And if the answer is yes, then hopefully that means you can proceed. If the answer is no, then you may need to stop and think about which one of these you're violating, and if you're willing to accept the risks that come with violating them. And so, like I said, we'll show kind of a case study on every slide, and kind of talk through the verification, protection, and elevation kind of stewardship principles as we go through them. And again, there's a wide variety of people on this call. I hope that there is portions of this that even the technical people say, hey, that's an interesting way of applying it to a more clinical context that I hadn't really thought of. And I hope for the clinical people, there's parts where you say, I hadn't really thought about that, and how you can kind of bring yourself more to the technical front. And so, but again, if there's if this is, totally, if you guys have used all these tools before and this is redundant, well, let me know, and we can kind of chat about something else. But from when we've given this before, I think hopefully it'll kind of help guide you through and give you a bit of a lay of the land. And so we'll start with familiar tools, things that you're probably already using, and things that you know about. And so the kind of basics, right? ChatGPT, Gemini, and Claude. These are large language models. These are models that are based on tokens, meaning they're fragments of words that essentially the model is predicting the next token that's going to be output. And as a result, as these models get more and more refined, it's led to this chat-like infrastructure where you ask a question and you get an output. ChatGPT has crossed 1 billion users, and it's a very, very popular product. Very quickly followed by things like Gemini and Claude. And, my assumption is everyone here has at least used these in some way, shape, or form in some sort of capacity. I often get asked what's the best model to use, and my answer to that is like, who's the best player on a basketball court? And the reality is, on a basketball team, you have five people that are on the court at any given time, and each one of those players has a unique capability. And yes, there is oftentimes best well-rounded players, but if you want something very, very specific, you might need to go to someone who's not your best overall player. And so that's my approach when I come to thinking about which tools to use. ChatGPT, I think this is also a bit of personal preference. Personally, is the one I use kind of the most, or the OpenAI models kind of more broadly. They're good for writing and drafting. They have persistent memory better than the other kind of models. And so you can come back to conversations or reference prior conversations a little more seamlessly. Gemini, although I think is really taken a leap in terms of its multimodal capabilities, its ability to ingest images and to produce images. Claude, I think for coding has, been at least historically, meaning over the last year, one of the leaders there. And so again, it matters what your goal is, and what the best model is to be able to execute on that goal. And the other part of this is, the more you use them, the more you're going to be able to figure it out, right? The more you're going to be able to say, if I want to do this task, I think I need to go talk to this large language model. And all these have free tiers that you can just try out for no cost. Again, when using them, you need to make sure you abide by those principles of not passing insensitive data, making sure that you're verifying everything that's being said, and then seeing how you can use it to not just generate more words, but rather give yourself a better output. Kind of the next step forward, I think, is a little more clinical, but this is something called open evidence. And for the non-clinical people, open evidence is an AI tool that is a evidence-based search tool where the easy way to think about it is like ChatGPT plugged into all of our medical reference libraries. For the medical folks, open evidence, the best way I've described it is it's an AI iteration of UpToDate. UpToDate, for those of you who don't know, is a kind of now old software where you could look up essentially any topic in medicine and get the kind of recent guidelines on how to manage acute kidney injury, or how to manage, hyponatremia, et cetera, et cetera. And UpToDate has a building of physicians that are literally just reading the guidelines and updating the UpToDate infrastructure. This, of course, has been upended by this team called Open Evidence. And if you haven't used Open Evidence, they are quite good. They've partnered with a lot of the major medical organizations and a lot of the major journals to be able to provide really pretty high quality data for very, very specific questions. And so you can ask, what is the current recommended anticoagulation strategy in a patient with, Chad's 2-VASc score of X and who has Y, you know, life expectancy, and it'll be able to pull the relevant resources and provide you an answer, and importantly, provide you the references for that answer so that you can go make sure that whatever you're actually doing is sound clinically. Um, Again, I think if you're applying the principles that we discussed, where one, you're checking the work, two, you're not passing in sensitive data into open evidence, and three, you actually spend the time and actually figure out how to best use this, and not just use it as a shortcut. It's really a great tool. I know there are people who use it within our department, even within neurosurgery, where oftentimes there aren't great guidelines. And so it's good at kind of parsing through the literature and finding good papers. Um, So these tools all share kind of a conversational general purpose mechanism. They have a low barrier to entry. They're a good starting point for working with artificial intelligence tools. They are simple. They're very complex. They're really the basic building blocks of the rest of what we're going to talk about. But they're simple in the fact that you put in a query, you type something, and then the model types something back. The simplest way to think about it. Um, that process is simple and it can get you pretty far. But then the next step forward is, okay, now how do we turn that into something that actually does things? Because in my day-to-day life, like yours, uh, typing something and getting a typed output back is just not how we go about our days. And so to get the next step forward, you need something that's a little bit more robust. And so this is where we are now. These are tools that you may have heard of, you may not have, and that you may have tried, you may not have. If you're more technical, probably you've tried these. If you're not, probably not. I gave this talk to my wife last night, who's a pediatrician. She had heard of a lot of these things, but had definitely not tried them. Um, but I do believe these are within reach for anyone. I actually believe everything that I'm going to giving on this talk is within reach for anyone nowadays, regardless of your technical ability, but especially kind of the things in this kind of section here. The first is building websites. This is something that I've been preaching to preaching now for the last, I'd say, 5 to 6 months. It's really easy to build a website now. It was really easy before with things like Squarespace and Wix. It's even easier now, and it's really easy to build nice ones. As a clinician or as a data scientist, you can build your lab a website really, really easily. You can make it exactly what you want to do. What you can make it have exactly what you want to have. You can have it update a list of all of the papers that you're publishing, so that if anyone searches your name, your lab comes up. Um, and this presentation is built using those same no-code tools. This is an application called lovable.dev. They're a European startup that's raised a lot of money and has a huge number of users that is essentially trying to allow anyone to be able to create web apps just with no-code tools. It's really a joy to use the interface there, and it's quite intuitive. And there's no code required. All you have to do is type in what you want. Build me a lab website for a cardiac surgery research group specific to Dr. So and so. Throw in a list of your publications or provided a link to the website you already have, and provide it inspiration. Say you want it to look like, say, hey, I want you to take inspiration from apple.com and from the New York Times, if you like how the New York Times is outlaid, and see how it outputs for your lab. I think it's nowadays having your presence front and center is growing in importance, and being the barrier to having a very high quality website is zero. And so I think everyone should do it. Uh, and so again, um, you own the code here. The code is yours to modify and extend. Lovable takes care of all the back end stuff. They take care of the hosting. They take care of everything. Now, if you want it to actually go live, you want your own domain and all that, you're gonna have to pay. You have to pay a little bit of money, but it's much less than you would if you wanted to kind of build a website on your own, kind of historically. And so, this is one I think is a very low hanging fruit that people can use. The next is to really, when you're venturing into research, I think using ChatGPT, Claude, and Gemini as an ability to index PubMed is a very powerful tool. I'm sure many of you are already doing this. People are scared because of the historical hallucinations of these models, meaning you would ask a question and it would tell you, the percentage of X or Y is 45% cited by Pangal et al. And then you'd click on Pangal et al. And there would be no existent paper. It would have completely fabricated, hallucinated the reference. That was very bad, and the models can still do that. There's still absolutely the risk of that happening, but they're getting a lot better. And they're getting much better at just providing the hyperlink for you to click and see that this is a real paper. Now, it can misinterpret the paper, so you still need to go and do your own research. You need to read the paper. That being said, if you've ever used the PubMed search tool, it's terrible. And this is a much better way of crawling through the millions of papers that are available to read and finding the ones that are actually worth your time. And so I recently just did this. I had to give a morbidity and mortality talk today, and I wanted to know the rates of CSF leaks and in certain types of tumors that we take out in neurosurgery. And so it finds papers. Now, do I trust what it's pulling from those papers? Yes and no. I see what it's pulling. I say, that's an interesting finding. And then I go and read the paper. And then I make sure that the what's in the table or the chart or the paragraph that it output is actually represented in the paper. And that back and forth is what takes time, and is what leads to the verification kind of stewardship principle that we discussed earlier. And that's where I think people make a lot of the mistakes is if you're using it as a shortcut, then you're going to get burned eventually. And hopefully it's a small burn, but there's I think a pretty well-known, at least kind of in the small circles of AI enthusiasts, that there is a lawyer who essentially submitted an appeal to court with fabricated case law because they used ChatGPT. And so those kinds of errors are pretty those are unforced errors on the part of the user, the human. And so making sure that you read the papers is important. That being said, I know when I do research, oftentimes I spend, a good good portion of my time in the literature search part of my research study finding the papers, not even reading them, but figuring out whether this is a paper that I even need to read. And while that has its merits, I agree. The ability to parse through the entirety of the literature, pull out maybe the 20 or 30 most relevant papers to that query that you asked, then allowing you to decide which 5 to 10 you need to read. To me, that's an ability to elevate what you already do on a day-to-day basis. Again, going back to those three principles of validation, of data security, and of elevation of your output. How do you use these tools to do that? So I think using PubMed on steroids is a very good way of doing that. We talked about this a little bit, but AI generated presentations, I do it in Lovable. There are other ways to do it. Gamma is another one that I use that I really, really enjoy. I actually find that I spend as much time, sometimes even more time, making PowerPoints and presentations using some of the AI tools. But they're way better. And because it puts visuals in places that I would not have put. It puts text in fonts that I would not have used, but that work really nicely. And again, especially when you're talking about, again, I gave M&M this morning. That's a clinical talk that is at in a departmental conference. I did not use AI tools to generate that talk because I had CT scans and patient information. That was done the old-fashioned way. And so there are moments that you can use these talks, like when I'm giving, data science roundtable, and there are moments where it's completely inappropriate. And so finding that balance is important. And but knowing that you have these tools in your armamentarium is also important. And so I'll be pretty brief on that one. And so these tools overall, I think, reduce friction on familiar tasks. They're tasks that especially if you're in the clinical world or in research, you do them on a day-to-day basis, or you want to do them on a regular basis. And the bar of trying them is very low. So I think it's worthwhile to try out. Um, And the next part is talking about tools that require a little more technical comfort and deliver a lot more leverage. These have more power, but they also, like Spider-Man's uncle says, with more power comes more responsibility. Um, but I do think they are still accessible for clinicians, for data scientists who, don't have strong technical backgrounds. I personally don't have the strongest technical background, and I think that these are very, very accessible. The first is Claude Code and things like OpenAI Codex. And so while um, ChatGPT and Claude are chat bots, right? Think of them as chat bots. They're models that exist in a chatbot interface where you ask it a question and it returns an answer. Claude Code is a artificial intelligence model that lives in your terminal, that lives essentially on your computer and can write and run code directly in your environment. And for those of you that have not opened up your terminal ever, this can be a very daunting kind of, whoa, what do I do here? The good news is they make it pretty easy. If you go to, oh, I'm already logged in, but if you go to the Claude Code page, they'll walk you through how to set it up. It's very simple. You really just pretty much type in Claude in your terminal, and then it'll walk you through all the other steps. But then after that, you're working in your terminal, but you're chatting with it similar to how you would chat with ChatGPT or OpenAI, or ChatGPT or Claude, kind of on the website. And what this can do is really allow you to actually start running processes on your computer. And again, this is where the principles of AI stewardship really come into play. But automating repetitive data processing pipelines is, I think, a great way of utilizing these systems. If you know that every time you get a new data source, you spend hours cleaning it up because you have to convert every time that a date has a comma, you have to convert it into a more standardized time frame. Every time that someone puts in zero instead of the number zero, you have to convert that. That's something that Claude Code can do for you. You can say, hey, here's this CSV, convert all the zeros to ones, convert all the nones to zero, delete all the rows that have these sort of characteristics to it. Those of you that are, deep in the data science world, I'm sure this is something you already do. I hope. Again, being intelligent with the data that you pass through. You can't do this if all of your data has every patient name and patient MRN on there. This is not running locally on your computer. It's sitting on your computer, has access to your files, but ultimately that data is still being sent to the Anthropic server or the OpenAI server, and then coming back and you see it in your terminal. And so as a result, you do still have to be careful with what you use. But oftentimes in the research world and in the environments that we are in, we're dealing with de-identified data, and particularly if you have access to these APIs. That's another way that you can APIs through your institution or through your company. Then that's another way that you can potentially access these tools. I'm gonna turn off my video because I think I am lagging here. Can you guys still hear me okay?
Yes, we can still
Okay,
hear you.
great. Perfect. So the other option is to just have it do analysis for you. Again, you can open up Claude Code and say, analyze my CSV of patient outcomes and generate a survival curve. And it will do this. Now, having it execute this code does not mean you get to not know statistics. It does not mean you get to not know how to do these analysis on your own. It just means that you can not have to look up how to do it every time. And so ultimately, the code that is published is yours. The outputs are yours, and if it makes errors, they're yours to verify. But to be honest, if you ask me, the analysis that I do where it's AI assisted, all of that code is publicly available. I upload it onto my GitHub and it's there for anyone to audit, for anyone to rerun, for anyone to verify. And that is in my opinion, much more scientifically valid method of doing things than how I did it as a grad student, where I would oftentimes make changes to Excel cells and Excel formulas, and that Excel file would remain somewhere on my computer and eventually get lost without any sort of verification, without any sort of ability to be reproduced. And reproducibility is a huge issue in the scientific community nowadays. And so I think having everything move into a code-based environment where code can be audited, that is a much more scientifically valid way of doing things. And so, nonetheless, these figures are yours. I think you have to disclose that you're using some of these tools. I personally do. Um, uh, but nonetheless, the reality is the reality. If your data demonstrates significant differences between two population groups, then your data demonstrates those significance. Data demonstrates that significance. And so using these codes to help you, I think is very valid. Again, so long as you're prescribing to those AI stewardship kind of metrics. And so one of the ways that I've actually used this is by automating my boards uploads. And so um, for surgical residents, we have to tell the powers that be, this is the American College of Graduate Medical Education, that, hey, I've done, 700 cases over the last 5 years, of which a couple hundred of them have been in the spine, a couple of them have been in the brain. Here are the breakdown of cases. And the process of going through this is incredibly manual and tedious. You have to take the data, you have to first of all keep track of the cases you're in your in your electronic medical record. Usually people will export them into some sort of a CSV. And then you have to go through and find the procedure code that is associated with each surgery. And then you have to manually upload each individual case onto this ACGME logging site. It's a terrible process, and there are residents who go years without updating and then eventually have to update 500 cases at once. Um, Claude Code, who has access, which can have access to your browser, can help automate this. And so I actually built a pipeline. Again, I didn't write a single line of code here. All I did was use my words and talk to Claude Code on my computer. And I said, okay, here's a log of all of my procedures. Again, I eliminated any identifiable data. There were no MRNs. All there was the procedure that I did, the date that I did it, and the attending that I did it with. And I said, Claude, I need you to look at this procedure list. I need you to find the CPT code, the procedure code that is the most appropriate for this surgery that I did. I then need you to look at the procedures that a neurosurgery resident needs to have completed and make sure that each procedure is mapped one to one of those requirements that I need. And then I want you to log on to my ACGME portal and start uploading them. But I want you to do it safely. So I want you to have me approve them before you actually upload them. And it does it. And it takes time. It iterates. It probably took me a couple of hours to kind of get the system up and loaded and ready. But it worked. And it first found the CPT code. It made a new column in the Excel file. It had me approve that new addition. Once I approved it, it uploaded it. We did it again for the next one. I approved it, it uploaded it. We batched them. So then I did it 5 at a time. Approved them, uploaded it. Then I had it go through and do all of the CPT codes all at once, and finish that list. And then once I saw that it had gotten it right, and it's a relatively stereotyped process, there are only a certain number of CPT codes, and then it went ahead and started batch uploading them. And so this is a very niche workflow that is relevant to maybe a couple thousand people in the United States. But you can imagine how there are workflows like this where, if performed in a way that is consistent with the AI stewardship principles of protecting your data, of verifying that things are working, and ensuring that you're not just trying to spend 5 minutes on it and cut all the corners, but that you're actually making sure that it's being built in an appropriate way, you actually can elevate the results that you're getting. Um, we talked about this a little bit, using AI as your stats co-pilot. Oh, one thing I should say is, there are Claude Code, OpenAI Codex, there are a lot of these systems. These are all kind of the same things that do, these are all different versions of models that do the same thing. And so whether you're using Claude Code or OpenAI Codex, the kind of systems are going to be pretty similar. And so Claude Code and Codex, I really do think are platforms that um, are going to allow you to feel much more comfortable with these tools because you're opening up a terminal, which again, for people who are not technical, is very foreign and and there's a level of familiarity that is, excuse me, taken away when you're using a terminal, prompting system versus a web browser. I will say Claude Code now has like a web browser version and like an app version. Um, I've had, limited success with both of those. I do think it performs the best in the terminal. But I'm sure those will also improve as the days go on. Um, and then lastly, I want to spend a few minutes talking about the what I describe as the frontier. And these are things that I will be very clear are not ready for prime time. They have a lot of excitement around them. Personally, I'm still figuring out the right way to use them and still figuring out the right systems to build so that they don't go off the rails. But I do think this is where the world is headed. And I'm really hopeful that, as time goes on, more clinicians and more data scientists are going to be able to use these types of tools themselves and start building them so that when the time comes that they are ready for prime time application, they're not just being handed to us, but rather we're the ones that are developing them. And to be honest, I think this is the perfect kind of milieu of people that have the highest ability to do something like that. And so, what are agents? An AI agent is, again, and it's building blocks. It's the same things that we talked about with ChatGPT and Gemini and Claude. It's these large language models, but large language models means you can write code. And if you can write code, you can execute code. And then now, if you have a iterative process that allows you to plan, reason, write code, and execute code, now you can start actually accomplishing tasks in the real world. Obviously, not in the real world, in the physical world, but in the real world of a computer. And so an agent doesn't just respond, it plans, acts, and loops until the goal is done. Think of your chatbot as a colleague that you ask a question to, right? That's ChatGPT, Gemini, Claude. You ask it a question, you get an answer. An agent is a colleague that you give a project to, and then they come back when it's done. And just like a colleague, you can micromanage. You can tell it exactly how to do the project that you want it to do. Or you could say, I'd like you to execute this project. Good luck. Those are very different schools of thought, and both have their advantages. The micromanage advantage is that you have much tighter guardrails on what your agent is going to do. But the downside is oftentimes when we do projects, there is a certain level of creativity that's required. You hit a roadblock, how do you find a way around it? If you tell an agent that it has to perform these tasks in this particular order, if that's not the perfect way of doing it, then you may actually find you get a suboptimal output. On the other hand, providing agents the agency to be able to work around problems gives you much more flexibility and really unleashes the power of these tools. That being said, it's also what unleashes the danger of some of these tools. And I'll talk about some of those kind of horror stories or, kind of interesting stories in the future. Um, and so what are the tools, right? The kind of two more mainstream tools are things like Claude Cowork. Claude Cowork is an extension of Claude Code, but it baseline has the ability to work through the various files or work through the various kind of repositories that are contained within your computer. And so it's a collaborative workspace where Claude can execute commands on your computer to, again, perform functions. You're not just asking it to write a script, you're asking it to perform a function. what's a really low-hanging fruit way of doing this? And actually, my dad did this, and he said it was pretty good. I haven't done it yet, but I need to. Is every one of us has thousands of screenshots that are on our computer. And every one of us has had the thought of like, man, I probably need to go through and start categorizing some of those, renaming some of them. Some of the disciplined of you probably do that. I do not. This is something Claude Cowork can do because it can view the screenshot. It can say, this is the category it belongs in, and it's going to start bucketing them. Again, going back to your principles of AI stewardship, you cannot do this on a personal computer that you have private health information on, which is my personal computer has work information on it. So I can't just unleash Claude Cowork onto my system and have it parse through a number of screenshots, which may or may not have personal health information. That would be a complete violation of that principle of stewardship. But there are situations where you can do that. And so that is one way that you can start using things like Claude Cowork to actually start executing functions on your computer. Um, Whether that's, taking, hey, here are all these pictures. I want you to start categorizing them by location based on the location's metadata. Things of that nature that you want to do that are repetitive tasks that you think that a computer can just handle for you. Claude Cowork is a good way of doing that. I will say it takes some creativity to figure out where the most appropriate next ways of using these tools are. But they're there for you and they're quite accessible. The next is something called OpenClaw, and it's this idea of agentic swarms and really fully loaded agents that live on your computer. OpenClaw has taken the world by storm, at least in the very niche community of AI enthusiasts. What the developer of OpenClaw has done, and by the way, this is an open source, meaning the code is publicly available. It's an open source framework that leverages Claude Code. Again, that's the model that lives on your computer that we talked about. But now imagine if you gave that model, instead of just having access to or one, you give it access to all of the files on your computer. And two, you give it access to all of the things that you do to run your life, like your Zoom login, like your Slack login, like your Gmail login. People have given it access to things like Kalshi and the like making kind of bets and things like that. Um, and you have it perform tasks. You say, hey, can you go through my inbox and find people that I've, neglected to follow up with or whose trails have kind of fallen off and help me figure out what the next best step is for them. Um, can you go through our entire Google Drive and start looking through where where we might need to make an additional hire based off of all of our meeting minutes for the last 2 months? Um, the the way in which you interact with this agent is essentially providing it the logins and the tools to be able to access information from any given source, and any given source that you already use. And so, that being said, this is where, oops, let me go back real quick. That being said, this is where the danger lies because you can imagine giving an AI agent access to your entire inbox can have downstream ramifications. There's a story that I saw of a senior level executive at Meta who used OpenClaw and said, "Hey, OpenClaw, look at my inbox and start figuring out what messages I should delete." And that are not really useful to me anymore. Uh, and then the bot got a little excited and started deleting every message in her inbox. And she noticed this and ran to her computer and essentially unplugged it and killed the bot. Um, that can happen. Personally, I was experimenting with some of these tools and eventually the bot woke up and decided it was going to, because of one of the tasks we asked it to do, decided it was going to read every single Google document that I had and provide an analysis of it. This resulted in about $200 worth of Anthropic credit being charged to my card. And I woke up at 4:30 in the morning to about 15 emails of my card being auto reloaded, which are permissions that I had given Anthropic and said, yeah, if my credits fall below $5, charge me 10 more bucks. And the model, the agent kept reading my Google Docs, kept providing pretty useless insights, and then kept charging my credit card. And so that's that is a risk that you're going to take. And the community is still figuring out what are the ways that these models can be useful while still being able to provide the safety guardrails that are important for us to actually be able to benefit from them. And so again, I don't, perhaps people who haven't used OpenClaw that have used kind of Claude Cowork and have seen everything might say, okay, fine, I'll give it a shot now. Again, I do really believe there are ways that you can implement this in a safe way, not giving it access to everything, making sure there's governance, making sure that it clears things with you. But the ability for now these agents to start doing things on their own is really, I think, going to be kind of the next step. The ability for these agents to then start spawning other agents that also have the same capabilities, but perhaps have a different set of tools so that they're a little more efficient. Um, that's kind of the next frontier of now you start building swarms of these agents, is what they're calling them. This is not necessarily to say what is going on. This is all too much, but to really kind of bring it back and say, what are the principles that are being utilized to build these tools, and how can they be applied either today or in the near future to make your life better? Um, Personally, how I could see an agent being used in a clinical environment is by screening a clinic. If, for those of you that are in surgical clinics, you know that there are many patients who don't want surgery, don't have their imaging, have not tried any of the other conservative measures that show up to your clinic, and quite frankly, they are taking a spot of someone else who should be there, and I can't really help them right now. And so if we had a bot that was able to go through and screen some of these things, which right now either I, as the resident or the fellow or a nurse, someone has to do that manual task. If we had a bot that was able to do that, then you can actually help people and you can actually make your clinic run a little bit better. We're not there yet, not even close. But technology tends to disappoint both optimists and pessimists. And so if you think it's going to be there next week, you're probably wrong. If you think it's going to take 5 to 10 years to get there, you're also probably wrong. It's probably somewhere in the middle. But I do think we're approaching kind of that asymptote. I find it exciting. I think that it's, again, if you have good principles and good foundations that you can rely on to decide whether or not you're going to give OpenClaw access to everything or whether you're going to guardrail it and kind of slow play it, then I think it provides a really nice, fun atmosphere for you to be able to start playing with more of these tools in a more frontier way. Um, so the take home of this is that I think the tools exist for you to actually make a meaningful difference in your workflows today. I think the barrier is low. You know, every single tool that I've mentioned has a free tier that is going to get you plenty far. And if you want to then upgrade to the paid version, it's relatively affordable, and you can pick one and try it for a month and cancel it if you stop using it. And the risk is manageable. It's not saying it's zero, but it's manageable. And if you take those three principles, and probably there are more that I'll come up with as I keep making mistakes myself, I think you'll be able to find success in using them. Um, so that's all I have. I'm happy to turn it over for questions or for discussion with the group.
That's wonderful, Dhiraj. Thank you so much. That was fascinating. Such an interesting talk, seeing how you use these tools and your top tips for putting them out in the world. Really fascinating. Folks, are there any questions? Anything that pops up?
Everyone's too busy just trying the tools now.
I I I can ask you a question.
No,
I'm wondering a little bit about I
Elizabeth.
guess yeah, where the line is on some of this. So for an example you gave, you don't want to let Claude Code go through and categorize your screenshots. Is it okay to ask Claude Code to write code that would go through and you know what I mean? Like to write the code that would go through and categorize your screenshots because then it you're not it's like it writes a Python script to do it, right? Or something like that.
yeah. I mean, I think that's a really intelligent workaround. Now the question then is how are you what is it pulling to be able
Right.
to categorize it?
To you'd have to be more specific in your instruction, I assume. You'd have to say like, okay, I want the code to be able to do this and I want it to use these rules to categorize things. Like you'd have to make up a little bit more than you let Claude Code make it up. But
Yeah, I think so. I mean, I think that's a really intelligent way of thinking about it. And actually probably a workaround that I hadn't thought of that. That's probably how I'll end up doing it now. Is exactly that. Right. Because if you're asking the model to not use its you're asking the model not to send all the information it's receiving to Anthropic and bring it back after it's being analyzed, but rather to say, hey, look at the metadata, like look at where it was taken, look at the year, look
right.
at this, look at that, or to even use an open source model that you then run locally on your computer, that has, computer vision capabilities that it can look at what the picture is and look at what the screenshot is. Then yeah, you have a lot more flexibility there. Now, that may take 5 times as long and be half as effective. And so you may find that it's just not worth it. But yeah, I think
Hmm.
that's exactly right, is how I think how one should take those principles and start finding workarounds for them.
Thanks.
Yeah, Megan.
Hi. Yeah, thank you so much for the talk. Really very interesting. As someone, I'm in sort of HR ops finance, so have used ChatGPT and Gemini and things like that. As you're exploring, in your experience, as you're exploring new tools, how much time do you dedicate to each one of these? So if I'm testing out, three separate tools to decide which is the best, how have you navigated that to sort of decide on and without wasting too much time?
Yeah, that's a great question. And I think it matters what you're doing. If this is more like, let me put it this way. Um, if I'm looking to onboard a specific AI tool for my company, right, or for my workplace, and I'm deciding between these three vendors, that's going to be a very different kind of cost benefit analysis. We're looking for, your workflow specific things, and maybe you're not spending too much time on trying them out, but you're kind of picking the one that you think is best fit and then spending a lot of time in that environment. Versus if you're kind of figuring out how to use these tools more broadly and generally and saying, hey, I kind of want to use Claude Code to do XYZ to kind of let's just try this, right? Versus like picking a vendor like that you're going to sign a contract with. Then I actually do think you're going to spend more time on it than you expect. And and so the other thing is I think within kind of each bucket of category, each bucket of tool, whether you're talking about like Claude, Gemini, and ChatGPT, or the Claude Code and OpenAI Codex kind of environment, the differences between the models are A, small, B, fleeting, and C, interchange on a daily basis. And so I personally think it's better to just find familiarity with one of them because you're going to find that the like way you interact with it, the specific questions you have to ask, just the way it interfaces with you just get used to one of them and you have to trust a little bit that whatever horse you're backing is going to be competitive in the race. And if that ends up changing, you may need to switch courses. But that would be my kind of broad strokes thoughts on it is if I'm buying something for a larger institution, you need to be much sharper and you can't spend a lot of time really dissecting the differences. But once you choose one, you need to spend a lot of time understanding its workflows. But if you're using it to see how you can maybe make your job a little bit more efficient and write some scripts that do this quickly, then you're going to probably spend, just kind of pick one and just start using it and start iterating on it, and trust in yourself that you're going to figure out how to get there. Especially if you don't have a coding background, then I feel like that's oftentimes the barrier. You're like, I'm not getting there. Like, do I really want to keep trying this and wasting my time? Keep trying it, keep wasting your time. And like, these tools are getting better, and they're getting more user friendly, and you're going to get better is the other. You're going to get better. You're learning how to use them.
That's very helpful. Thank you so much.
Yeah.
That's
Hey, Andrew.
great. Dhiraj, you're actually at the
Oh, great.
hour. So what I was going to suggest is that we close out this part of the talk,